These notes are on operations on irrational numbers. So the first thing we're going to look at is adding and subtracting irrational numbers. So rational numbers kind of have some similarities to adding and subtracting like terms. So for instance, in my first example here, square root of 2 plus the square root of 8, I can't add these as they're written because they're not like terms. So in order to get them to be like terms, I need to be adding two numbers where the number under the square root are the same. So the question really becomes, can I rewrite either the square root of 2 to have an 8 underneath, or the 8 to rewrite the square root of 8 to have a 2 underneath? And it turns out that I'm going to work with the square root of 8 because that can be simplified. And that's my clue here, is to always try to simplify the square roots as much as possible before adding or subtracting them. So I know that the square root of 8 is the square root of 4 times the square root of 2. So I know that the square root of 4 is 2 times the square root of 2. So now I've rewritten this so that I have like terms. I have a square root of 2, invisible 1 in the front, and a square root of 2 with a 2 in the front. So I have 1 square roots of 2 and 2 square roots of 2, which means I have a total of 3 square root of 2. My second example, I actually don't have any square roots of 2, but I look at this and I say, well, I have a perfect square here hiding, I have a perfect square here hiding, and I have a perfect square here hiding. So I'm going to simplify that. The square root of 50 can be written as the square root of 25 times the square root of 2. The square root of 32 can be rewritten as the square root of 16 times the square root of 2. And negative 2 square root of 8 can be written as negative 2 square root of 4 square root of 2. So now I look at this and I'm like, oh, this is really nice because I have a square root of 2 and a square root of 2 and a square root of 2 in each of my 3 terms. So now I have to see if I can simplify the other numbers so that they don't have square roots. And I can. Square root of 25 is 5, so I have 5 root 2, plus square root of 16 is 4 root 2, minus 2 times the square root of 4 is 2, square root of 2. Combine my like terms, square root of 2 and square root of 2, that makes 9 square root of 2. Negative 2 times 2 is negative 4 square root of 2. 9 root 2 minus 4 root 2 is 5 root 2. So this seemingly complex initial problem actually simplifies down to one number. Our next example, in this case, we have 3 terms and 2 of them already have a like term. They already have a square root of 3 in both of them, and the 4 doesn't. And the 4, it already is simplified. It's not a square root of 4, it is just 4. So when I combine my like terms here, my 4 doesn't combine with anything, it stays 4, and my like terms here give me negative 2 square root of 3. My next example, my last for adding and subtracting irrational numbers, in this example, it turns out that my like terms in this case are the ones that don't have any square root. I can't simplify the square root of 3, and I can't simplify the square root of 5. So they simply stay, excuse me, the square root of 3 and the square root of 5. So I end up with 8 minus 11, so negative 3, and then minus 5 root 3 plus 3 root 5. These can't be combined. They're as simple as they get. So complicated looking problem, not that much simpler once I simplify it. The second part of these notes has to do with multiplying irrational numbers. We're going to talk about in the next notes some more details about this, but I just want you to notice that in the examples we have here, both the 2 and the 3 are positive, and both the 8 and the 6 are positive. So if you'll remember, we can rewrite this as the square root of 2 times 3, which is the square root of 6. For our second example, I can rewrite that as the square root of 8 times 6, which is the square root of 48. But I need to make sure that I can't simplify these. Well, the square root of 6 does not simplify, but the square root of 48 does. And so I can rewrite that as the square root of 4 times the square root of 12, which I can rewrite as 2. Square root of 4 is 2, and the square root of 12 is the square root of 4 times the square root of 3. Still have my 2. Square root of 4 is 2. Still have my square root of 3. So square root of 4, square root of 3. So the square root of 8 times the square root of 6 is 4 square root of 3. The last example we're going to look at with multiplying irrational numbers is where we kind of have binomials being multiplied. So I'm going to use distribution. So I'm going to double distribute 4 to both pieces. So 4 times 3, 4 times negative 2 root 2, 2 times root 3, root 2 times 3, and root 2 times negative 2 root 2. That's negative 2 square root of 2 times the square root of 2. Combine some like terms. I've got 12 minus 5 root 2. Over here, however, I can simplify this to be negative 2 times the square root of 4. But I know the square root of 4. Square root of 4 is 2. Excuse me, that should be a subtraction sign. So now I have 12 minus 4 minus 5 root 2, which is 8 minus 5 root 2. So 4 plus square root of 2 times 3 minus 2 root 2. And again, just to emphasize the fact that all of these numbers, the numbers underneath the square roots, are all positive. Square root of positive 2, square root of positive 3, positive 8, positive 6, positive 2, positive 2. And so we're going to have to look at what happens when any of those numbers turns out to be negative. And we'll look at that in subsequent notes.